In this chapter, let's understand about union, how union works. Before union, let's take one example for a struct. Okay, so we have a struct example. In this example, we have a character array and the int b and the float c. This character in this struct, this character will allocate 2 bytes. Integer will allocate 4 bytes. We are assuming this the compiler we are using is a CPU width of 4 bytes. That's why integer will have 4 bytes. A float again will have 4 bytes. Total 4 plus 4 8, 8 plus 2 10. 10 bytes will be allocated in the memory. So this first 2 bytes will be allocated for A. Next 4 bytes will be allocated for int, and again the C will be allocated with 4 bytes. So total 10 bytes will be allocated in the memory for this struct. The same example uh, for the union, the same number of elements, but there is a catch here for the union. Union will allocate, union will also calculate in the same way, uh, 2 bytes. This is 4 bytes. This is again 4 bytes. But it will allocate so total, so it will calculate which one is the biggest. So 4 byte is the biggest. In individual element, it will check which is the biggest. So 4 byte is the biggest. So it will allocate the 4 bytes. And the A, B, C all will be pointing to the same memory location. So here you can see the A is pointing first 2 bytes, then B next 4 bytes, and C for the next 4 bytes. But here all A, B, C will be pointing to the same 4 bytes, but A will have first 2 bytes, then B will be pointing to next 4 bytes, and C will be accessing the same 4 bytes here. So whenever you write or read, so whenever you write, it will write into the same memory, but if you write character, it will write 2 bytes. If you write integer or float, it will write 4 bytes, but the same memory location. And reading, if you read character, it will write 2 bytes again. For the int, it will write 4 bytes. Same for the float. But same memory location will be used for all the elements, but the maximum byte will be allocated in the memory. Thank you.